Hello learners, welcome to session 6 of Unit 2 in the course Introduction to Abstract Algebra. I am Unkala Dasmani and I'm your course instructor. In section 6, we are looking at well-ordered relation in a set. In the previous session, we looked at a partial orders. So we are going to extend the idea of a partial orders to a well-ordered set. By the end of this session, you should be able to identify and describe well-ordered relations on a set, give examples of well-ordered relations on a set. You should be able to identify applications of well-ordered relations on a set. Before we look at well-ordered relations on a set, let's look at what a chain means. A chain, given a partial order relation on a set S, a chain in S is a non-empty set or non-empty subset A of X that is linearly ordered with respect to the relation, the order relation. That is for all X and Y from A, either X relates Y or Y relates X. And that is what we call a chain. That's what we call a chain. So let's look at small history. The concept of a well-ordered set was introduced by Cantor in 1883. A partial order on a set that has this further property that any two elements are comparable is called a linear order. So example is the usual order relation on R or is a linear order. Let's look at definition for well-ordered relation on a set. A poset X, this one is a poset. Once it satisfies the three conditions, it's called a well-ordered set if every non-empty subset of S contains a smallest element. So this definition implies that a well-ordered set X is automatically a chain. So we have A, which is not equal to B, are members of X. Then set AB has smallest element. So either A relates B or B relates A. Then it contains that smaller element. So natural numbers and all its subsets are well-ordered. And the set of integer Z is not well-ordered since, for example, Z itself contains no smaller element. So R is not well-ordered since, for example, the empty interval 0, 1 contains no smaller element. So the Z1, she can be all negative, can be all positive. So no smaller element, not restricted. But natural numbers, we know they are excluding negative. So there's a smaller number for it to be a natural number. Okay. Since a well-ordered set X is a chain, it has an order type. So you can find more in your course material. There are more examples out there.